Welcome to Fire Engineering's Training Minutes. I'm Adam Hansen.
I'm Anthony Deko.
Many times we get a call for an odor of something burning in a commercial type occupancy. Most of the times we arrive to find nothing visible from the exterior. This forces us into an investigation type mode. Upon making entry into the front of the building, we're many times presented with an odor of something burning and or possibly a light haze of smoke near the distributor vents of the ductwork. At this point of the incident, IC typically orders someone to check the roof. Upon the many things we're doing on the roof, one of the major things that we're going to be doing up here is checking the HVAC equipment. There's several different systems of HVAC equipments. However, in this Training Minute series, we're going to be focusing on packaged rooftop units, otherwise known simply as RTUs. Whether you're working in the busiest cities or the slowest of suburbs, you either have or will get calls involving these units. So it's important that we know the components. So in order to be better firefighters, we need to become familiar with the actual components that make up these rooftop units. Let's start with why they call them that. A packaged rooftop unit. You're going to find 90% of these units are located on the rooftop, and unlike a home system, which is a split system where you have sections inside the house and the condenser and the compressor on the outside of the house, this is all packaged into one confined unit. It's pretty simple once you get familiar with it. This right here, the exterior box, might not seem important, but it is. It's constructed out of galvanized steel, and this is going to protect it if you're down in the Denver area from the hot heat in the summertime, or up here in the Northeast when we get sleet, snow, wind, rain. It's going to protect these very important components from the exterior environments, and it's going to encapsulate the unit and keep it all sealed off. Let's move down to the air handler. This is the air intake. It's kind of a misconception that 100% of the exterior air comes in through the air intake and is utilized 100% of the time throughout the day. Actually, about 10% of the air comes in through the air intake, and about 90% is recycled throughout the day as it's cleaned and processed. One thing that Anthony will show you right now, there's usually a screen on the bottom, and this isn't going to protect the exterior contaminants such as dust and debris. It's more going to keep out the rodents, and it's going to keep out the leaves. Once you get a bird, a raccoon, a squirrel in there nesting up, they will burn up, they will die, and who are they going to call? When there's no one else to call, they call the fire department, and it's one more 911 call that we're going to have to go on. Moving down, we have the air filters. It might seem like a very simple component, but it's something that is overlooked all the time. I've been up and investigated rooftop units where that filter is original to the rooftop unit, which is 15 years old and hasn't been cleaned. If that is the case, it's going to create a mess on downstream components, and it's going to collect dust on the motor and cause the motor to burn out, and again, activate the 911 system when it's not really necessary. The next portion is the evaporator and the evaporator coils. It's a fallacy that HVAC systems actually cool the air. As the air passes over the evaporator coils, the coils actually extract the heat from the existing air, and that's what's actually cooling the air as it passes over and is pushed through the ductwork throughout the system. One way to identify the evaporator coils, besides seeing them, is locating the cold and the wet side. When the cooling function is on, these coils will be cold and they will be wet to the touch. And again, that's the evaporator and evaporator coils. Moving down, this will be a big culprit as to why we're getting a lot of our 911 responses involving RTUs. If you see inside, Anthony will point out, you have the motor, which spins a V-belt, a rubber V-belt, which in turn affects the squirrel cage blower inside. That is the portion that actually moves the conditioned air, whether it be heated air, cooled air, or just cleaner air. That is what's pushing it through the ductwork out into the different compartments in the actual building. Moving on, we have the compressors. This has been referred to as the heart of the cooling function of an RTU or an HVAC system. It is responsible for the entire heat transfer cycle. It takes the refrigerant from a low vapor pressure and transfers it to a high vapor pressure and back and forth. And this is really what allows the cooling portion of the HVAC system to work properly. Without it, it's not going to happen. If you look through there and up here, this is called the condenser and the condenser fan. Just like a fire pump, when you take in water, the water has to go somewhere and it has to be discharged back out of the hose lines. Once we took in that hot air out of the air in the evaporator coils, it needs to be discharged back out into the atmosphere. And that's what this is for. Just like the evaporator coils where you could identify it by the cold and wet side, this is going to be the complete opposite. This is going to be the dry and the hot side. There's a fan on top that spins, which I'm sure you've all seen, and that is actually pushing that hot air out into the atmosphere. So far, what we've been talking about is the air conditioning and cooling aspect of the RTU. When the building is calling for heat, it's going to start its burners, and the burner and the heat is going to enter these coils right here, and this is called a heat exchanger. You will see later on why knowing where the heat exchanger is and what it does is crucial to us investigating these units, because it can create an actual IDLH environment and be dangerous for the people operating inside of the building. I hope this was a good basic overview of the major components which make up a rooftop unit. I hope that it helps you when you're investigating these units and also as we proceed throughout this Training Minute series. Again, my name's Adam Hansen.
I'm Anthony Deko.
And thanks for tuning in to another episode of Fire Engineering's Training Minutes.